So for part B of this question, we're asked to draw the plan and elevation. So I've just done a little kickstart on this. So I brought down my y-axis vertically, point B and point Z vertically, and I've just picked a horizontal line where I want to start this drawn off. Okay, you can see from the question then you have to, well, the y-axis will be the center point. You draw your semicircle here, giving you a perfect 45-degree angle from there on all intersections of that semicircle. Okay, on this 45-degree line, we're told in the question you measure down 20 mil, 40 mil, and a further 20 mil. So if I bring those points down at 45 degrees, this is the hardened edge of one of the sides of the hexagonal polygon. So if I want to go, and we know the angle, of course, here will be 60 degrees. That's the external angle of a polygon or of a hexagon. So if I set up my set square at 45 degrees, I can then put the 60-degree angle in line with it to draw a 60-degree angle here, and of course flip it round in the opposite direction to get your 60-degree angle here. And likewise do the same thing in this direction. So 60 degrees here and 60 degrees. And that will leave you exactly with a 45-degree line here, and there is a 40 millimeter length of side polygon. Okay, so inside that, if we half these distances, so if that's 40, we measure across 20. Likewise, we can do that with all of them. There isn't much of a quicker way of doing that. So 20 here, 20, 20, 20, of course here as well. And then that gives you your hidden detailed hexagon on the inside. So I'm going to pause that while I harden that in. Okay, so that gives you your hidden detailed internal hexagon. Now, going to go on with my elevation. So likewise, similar to the way in which we did the plan, I'm going to extend out points A and C. So setting up my angle, just checking that angle first of all. That angle is less than 30 degrees. So I'm going to use parallel set squares. Slide out point A, point C. And then parallel to the line AC, just going to bring out a construction line wherever suits me. And that's going to be the base of my semicircle. And I need to bisect that line. Okay, I'm just checking you can see that. So there to there. There to there. Move this over. Pause this for a second. Okay, so I'm going to continue with this. I'm going to bisect this angle, or bisect this line. This being my bisector. A semicircle. And where my z-axis intersects the semicircle, this gives me the angle that I'm going to use to construct my elevation. Okay, so this will be the baseline of my elevation. This would be considered the vertical lines of my elevation. Heights. If we measure up 20 millimeters here and down 20 millimeters from this intersection point there, that's going to be the top line of my elevation. That's going to be an important line there. And here we go. So there are the appropriate heights that I need for the elevation. Now I need to take the widths up into the elevation. So we know that this was 20, 40 and 20. So I'm going to apply the exact same widths up here. So 20, 40 and 20. And I'm going to bring those heights up through the rest of the drawing. So up here and here. And again, hardening those in. So I'll just harden these in, I'll come back to you. Okay, so I've just hardened in the top section and the bottom section. And the rest of this question can just be finished by hardening in this point to this point. So again, just following the lead from the exam question. This point hardens up to that point. So look at the exam question and just harden it in as given. And that's the elevation and plan complete. Therefore, part B is now complete.